All right, so to continue, this is page 4, chapter 1, 1.3. So we were talking about histograms. Histograms are a good representation or a good way to show what your frequency distribution or your for your quantitative data, and just a nice visual representation of your data for others to see. So a frequency histogram is a bar graph representing the frequency distribution, I'm reading right here, of a data set. The vertical scale is always the frequencies. The horizontal scale is either the midpoints or the class boundaries. For a relative histogram, the horizontal scale is only boundaries. So here are 3 graphs that we can use to answer the questions over on the side here. So the first graph is, it says prices of the GPS system navigators, and it's labeled with class boundaries. So the second one is prices of navigators that's in a relative frequency scale. Notice that the scale on the first one is 0 to 10. The scale on the second one is 0 to 30%. So they're just using the relative frequency versus the frequency, but it's still on the y-axis. The last one is 0 to 10, so it's a regular frequency, but the difference is the top one is using boundaries on its x-axis, and the bottom one is using midpoints on its x-axis. So let's see what we need to answer questions about the data for these. So it says use any of the 3 histograms to answer the following questions. So what's the minimum price or the lowest price of a GPS navigator that we had in our data set? Well, by definition, the lowest one is a half a point above the lowest boundary. So if the lowest boundary is 58.5, that means the minimum price was 59. It's just above that, okay? $59. The maximum price is somewhere in this last class. I talk about the different classes. Look, 1, 2, 3, 4, 5, 6, 7 bars, okay, in the histogram. So 7 classes in the histogram. The lowest boundary is 58.5, so the lowest price has to be 59. But the last bucket, class number 7, had to be big enough to hold the last price, whatever it was. It can't be any larger than the last boundary, so it's a half below the last boundary, which is $450. So this, I call them 7 classes, 7 buckets. The sides of the buckets are the boundaries. The buckets themselves hold the data points which fall inside the buckets. Okay, does that make sense? So the lowest price is 59. The highest price has to be below, at or below 450, right inside the last boundary. So the number of classes was 7. The prices range from 450 to 59, which is the range of 443. So we get in the habit of calling a range a couple of numbers. It's from this number to that number. But technically, in statistics, where that comes from is one number tells you the range. So in this case, it's 450 minus 59 gives you 443. So the range is 443. So on the test, don't give me the range 450 to 59. You want whatever that is subtracted for one number, okay? The class width, so how wide are these bars? Not just how wide, but what from number to number. So you can go from class midpoint or class boundary to the next one, not the numbers inside. So we're talking edge of bucket to edge of bucket. So you can do 142. Oh, that's the midpoint down at the bottom here, 142.5. So midpoint to midpoint, 142.5. Put the bigger one first because you don't want a negative number for a width. So put the bigger one first. That gives you 56. But the boundaries we can do 114.5 minus 58.5 is going to give you 56 as well. So the class width is 56. And the lowest boundary in the first class is 58.5. The upper boundary first class is 114.5. The lower class limit would be inside the bucket, so that'd be the price. The upper class limit of the first class. So the upper class boundary of the first class is 1145, which means the price is 114. How many navigators were included in these results? Look at the first one. If you add them all together, 5 plus 8 plus 6 plus 5 plus 2 plus 1 plus 3, I believe that comes out to 30 different navigators is the frequency. Add all the frequencies up and get the total frequency, gives you the sample size. N stands for sample size. So there's 30 in this sample. And the last one says, in which class do most of the GPS navigators fall? That would be in class 2. Answer A through D about this class, number 2. Okay, what is the price range in number 2? The price range, not the boundaries, not the midpoints, but the limits in 2. Let's see. The boundary is 114.5, so that's inside the bucket would be 115. And below the upper boundary would be 170. So the price range is from 115 to 170. So in that context, I do want the two numbers, okay? What is the average price? The average price, you have to look at this last one. The average price is 142.5. That's not a boundary, that's a midpoint. So that's the average, that's the center of that class. So that would be the midpoint. Approximately what percentage of GPS fell in this class? What percentage? Well, we know 8 fell in out of how many? 8 out of 30. So that comes out to 8 divided by 30 is 0.26 with a repeating 6. Kind of approximately 20 times it times 100. So approximately 27% of the GPSs out of the 30 fell into the second class. And then it says how many fell into this class and below. So the cumulative frequency for the first two classes would be 8 plus 5 is 13. Okay. Next page. Here's a picture of a dot plot. Dot plot below shows calorie counts for 20 beef hot dogs. So 20 different ones. So the sample size was 20. And they put a little dot for each of the 20. So in a dot plot, it's very good for a small number of data points because you can see each individual one. In the histogram, we couldn't see that. This one, you can see that there's repeats in a couple of places. It's just a nice, simple display along its x-axis. It's a good way to display individual numbers. Stem and leaf plots are another way to display. This is a stem and leaf plot over here on the right. The 6 through 12 is the stem. All these others are the leaves. Okay. There's always a key for stem and leaf plots. That means that 6 with a line in between and a 4 means 64. It says over here that stem and leaf displays showed the distribution of quantitative variables, right? All numbers. Like histograms do, preserving individual values. So dot plots and stem and leaves, you can see each individual value, but on a histogram you can't. So that's an advantage. So obviously stem and leaf and dot plots are good for a small set of data. You can turn the stem and leaf kind of, if you turn your head a little bit, you can turn sideways and you can still almost get a feel that this is a bimodal. See this peak and their peak there. The second you can't really call it a class. Let's call it the second stem from the top is quite tall. If you turn it sideways, that means more data points fell in this that began with the 70s. So in the 70s, remember this 6-4 or the line or whatever, it makes 64. So if you can picture the data, so that means one number was 64, comma, if you line them all up, 64, 65, 67, 71, 71, so there was two 71s, okay, two 72s, 76, 77, 77, 79. So there was quite a few 70-somethings, and there's quite a few 90-somethings, 90, 92, 93, 94. So that's why they look like peaks if you turn it on the side. So you could still say they're a little bimodal. So n is 27. If you count all the leaves up, you're going to get 27. The minimum data value was 64. The maximum data value is what? It goes all the way down from 6, 7, 8, 9, 10, 11, 12. And there's only one leaf on the 12 stem, so 125. So that's the maximum value. That's how you read these things. So let's see if we can make our own stem and leaf out of the following data. So it says step 1, cut each data value into leading digits. I got to tell you, the first thing I did was put them in order, because just seeing a big sea of numbers, I counted them, and apparently if you go 2 down and 10 over, n equals 20. So there are 20 data points in front of us. It won't take long to line them up. I kind of go through and I try to find a minimum first. 17's the minimum. And then as I use them, I cross them out. So 17, 18, 19, so and so forth. So I'm going to just write them all down. So 17, 18, 19, 21. There's two 21s. You need these. You need each and every data point, even if it's the same. Remember, frequency says it's been repeated, so we need to know when it's been repeated. So I just go through and write all the numbers in order, which I already did, which is why I'm doing it really fast at the moment. Oops. 39, 44, 45, 48, and then there's a 58 is the maximum. Okay, so what did my stem have to look like? Well, the lowest number is 17, so I can write a key for a second. 1/7 is equal to 17, so that's my starting number. You cut the digits in half. Stem is the 1, the leaf is the 7. That's where we're starting, okay? And then we number the rest of the leaves. Don't put commas in the middle. It's just 7, and then there's an 18 and a 19. So that's the stem is 1, and the leaves are 7, 8, 9. Then you come down on the stem to 2, and there's a 21, 21, 22. Try to keep everything lined up so you'd be able to see if there's peaks or not. Let's see, 21, 21, 22, 24, 25, 26, 27, 29. Try to put them nicely spaced. Then there's a 31, so 3 in the stem, 1 in the leaf. 32, 35, 37, 39. Then there's a 4, 44, 45, 48. And then the last one is a 58. So your stem can't skip any gaps. If there coincidentally hadn't been any 40 anythings and I needed to get to the 58, you still have to write the 4. Don't put the 0 if there's not a 40. So you have to write the stem continuously. It says on here, let's see, right here, number the vertical stem starting with the lowest value or the minimum at the top leading digit down to the highest maximum number, right? Skipping no values. So if I had no 40 anythings, I'd still put a 4 in the stem because you can't skip anything in the stem, okay? It's important to see that there's no 40s, that there's a gap. All right, so if you turn your head a little sideways, you can see that this looks like a unimodal shape, right? Because there's one peak in the 20s, so 20-something was the most common. Let's go back to context here. This says the following data represents the ages of people attending the political rally. So you can say something like the most of the people that were there. The most common age is people in their 20s. There was one person in their 50s. So the range, the youngest person there was how old? 17 years old. The oldest person was 58. You can see that, let's see, 1, 2, 3, 4, 5, 6, 7, 8. There's 8 leaves in the 2s. So 8 out of 20 would tell you 8 divided by 20 is 0.4. So that 40% of the people attending the rally were in their 20s. Okay? 15% were under 20. 5% was over 50. Get an idea. See how it's giving you a picture of the people that attended. All right. If you are in class, we're going to do some more stem plots, look at a little more construction, frequency polygons. So there are always going to be a little more in class than I can do on these videos, but this at least gets to the lectures, and the page number should be there for the other things we may or may not have done depending on how much time we had. Thank you.